Hello, in this video we're going to determine the shortest distance from the point negative 5, 2 to the line represented by the line y equals x plus 1. So this is a pretty standard problem. And what I'm going to do to start this problem is I'm going to draw the line and I'm going to draw the point on the graph. Now again, we don't want to rely on graphing these and reading the answers, but we want to understand that drawing sketches of graphs are kind of good ways to help give us clues about how to approach a problem. So yes, at this stage, a lot of the time it will give you the answer because we often give you nice numbers. Really, we want to think about the sketches as just a guide of sort, to give us ideas about what next steps to try. So we graph this line y equals x plus 1, so we have a y-intercept of 1 and we have a slope of 1, so there we go. I'm going to remember to put my arrow at the end. Here we go. I'm going to remember to put my arrow at the end. I'm also going to remember to use the whole graph. And I'm going to put the point 5, 2, negative 5, 2, which is here. Now, again, I'm going to have to talk about this point, so I'm actually going to give it a name A. And I'm going to actually name this line L1. So the underlying principle with this question is that when we're finding the shortest distance from a point to a line is, what we essentially do is we actually find the line that passes through the point and intersects our other line at 90 degrees. So this intersection is 90 degrees there. So what I'm going to do is I'm actually going to, I need to calculate this line, and let's call this line L2. I need to figure out what this L2 is. And then I need to figure out the intersection of L1 and L2, and then I can find the distance between those 2 points. Now that being said, we can actually, I'm pretty sure that this is correct, and this is the point where these 2 lines intersect. However, let's make sure we can do this algebraically. So notice I've drawn this diagram here, so we're going to start with this. So let's work in gray. So the slope of L1 is equal to 1. And since L1 is perpendicular to L2, the slope of L2 is equal to the negative reciprocal of the slope of L1. So therefore the slope of L2 is negative 1 over 1, which is equal to negative 1. Okay? So if the slope of L2 is equal to negative 1 and line 2 contains the point A, we can then say y is equal to negative 1 x plus b, and then we're going to sub in A into here, so 2 is equal to negative 1 times negative 5 plus b, so 2 is equal to 5 plus b, b is equal to minus 3. Therefore, L2 is the line y equals negative x, minus 3. And I look, and it's actually, I've drawn this perfectly. And I can see on this, I'm pretty sure that the point of intersection here is negative 2, negative 1. Again, this happens to work nicely. It's not always going to be this way, so make sure you understand the algebra here. So the next step is I need to find the point of intersection between these 2 lines. So let's actually change our colors here. Let's go to pink. So the next step is we're going to find intersection of L1 and L2. So therefore, let's write line 1 down, y equals x plus 1, and let's write L2, y equals negative x minus 3. Okay. Let's add these 2 equations. So we're going to get 2y is equal to negative 2, y is equal to negative 1. Perfect. If y is equal to negative 1, therefore negative 1 is equal to x plus 1, x is equal to negative 2. Therefore, the point of intersection, the POI, is negative 2, comma negative 1. And again, I can come back to my graph and look, and I feel good about that. So therefore, if we want to find the shortest distance now, let's change colors again. Let's change to black. Like I was saying, I had a little hiccup there, so I don't know if it looked funny in the video, but therefore, I have to find now the distance from negative 5, 2 to negative 2, negative 1. So our distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So therefore, the square root of negative 5 plus 2 squared plus 2 plus 1 squared, right? Negative 5 minus minus 2, 2 minus minus 1, which is going to be the square root. Let's scroll down a little more here, of negative 3 squared is 9 plus 9, which is the square root of 18. And there's our distance. Now, you could leave it like this, or you could go and you could write it as a mixed radical. So you could write this as 3 root 2, or you could say d is approximately equal to, and you can actually get your calculator out, and you get approximately 4.243. That's approximate. Again, any of these answers are acceptable. If there's no reason to write it as an approximation, just leave it as a radical, which is a number under a square root sign. I hope that helped.